This film covers all you need to know to answer IGCSE questions on sequences. Chapter 1 deals with how to find the terms of a sequence when you know the nth term formula. Chapter 2 gives you a chance to practice this using a Blooket. Chapter 3 shows you how to use the nth term formula in other ways. And in Chapter 4, how to find the nth term formula yourself when you're given an arithmetic sequence. Chapter 5 gives you a chance to practice that, again using a Blooket, before Chapter 6 shows you how to use the difference method to extend a sequence. And the last how-to, how to find the sum of an arithmetic sequence, is covered in Chapter 7. Chapters 8 and 9 are full of IGCSE past exam questions. Each time you have an opportunity to have a look at the question, give it a go first, and then to watch me do the question in a walkthrough. So I hope you find these films useful. Please do feel free to leave a question in the comments, and I'd love to know how you're finding the films, what I could do to improve them, or what is working well for you. So please do feel free to leave a comment anyway. Right, good luck. Mr. Right here, we're going to work out the terms of a sequence from the nth term formula. So, for example, in question 1 here, we're given the formula for the nth term of the sequence. The formula is 5n minus 6. So, from there, we can work out any term we want to. If we wanted to work out the first term, for example, we wouldn't do 5 times n minus 6, we'd do 5 times 1 minus 6, because n is 1, because we're working out the first term. If we wanted to work out the second term, we'd do 5 times 2 minus 6, because n would be 2 this time, because we're working out the second term. So this sequence starts minus 6, and the second term is 4. Let's have a look at the second example here. Number 2, this time the nth term is 100 minus 3n. So if we wanted to work out the first term, we do 100 minus 3 times 1, which would give us 97, and we can work out any term we want to. For instance, the 10th term would be 100 minus 3 times 10, because if we're working out the 10th term, we substitute in n equals 10, and that would give us 70. Let's have a look at number 3, and you might like to pause the film in a moment or two and have a go at some, and then see if you and I agree. In number 3, the nth term is a half multiplied by n minus 1. So in a moment, I'm going to work out the first term, and I'm going to work out the 5th term. So why don't you pause the film now and do those, and then see if we agree. Right, the first term would be a half times 1 plus 1. Well, that's a half of 2, so the first term is 1. And the 5th term would be a half of 5 plus 1, which is a half of 6, so the 5th term would be 3. Lastly, let's look at working out terms of the sequence given to us in question 4. In question 4, the nth term is n squared plus n plus 1. So let's work out the first 4 terms of that sequence. So I'm going to work out T1, T2, T3, and T4. Pause the film now and have a go yourself. Right. The first term would be 1 squared plus 1 plus 1, which would be 3. The second term would be 2 squared plus 2 plus 1, substituting 2 in instead of n, which would be 7. The third term would be 3 squared plus 3 plus 1, which is 9 plus 3 is 15. Sorry, it's not, it's 12 plus 1 is 13. And the fourth term would be 4 squared plus 4 plus 1. 4 squared is 16, plus 4 is 20, gives me a fourth term of 21. So this sequence looks like this. It starts with a 3, then a 7, then a 13, and then 21. So that is how to work out terms of a sequence using the nth term formula. If you found this film useful, please do hit like, and then the algorithm will spread the word. Here's a Blooket for you to use if you want to practice finding the terms of a sequence if you know the formula for the nth term. Simply click on the link which is in the description of this film, enter your name, hit the arrow, hit start. No, you don't want a tutorial. Find the first term of the sequence given by this rule. If you're finding the first term, then n will be 1. So it's going to be 10 plus 8 times 1, 18 red. Find the 10th term of the sequence given by the rule 2 times n. So 2 times 10, 20. Find the 5th term of the sequence that's given by the rule n. Well, n will just be 5. Find the 10th term of the sequence given by the rule -1 plus 10n. Well, that's going to be -1 plus 10 tens, so it's 99 blue. Find the 5th term of the sequence given by the rule -8n minus 1. Well, -8 times 5 is -40. -1 is -41. I'm sure you get the idea. Mr. Right here, there are some other ways in which you need to use the nth term formula for a sequence. And to illustrate these to you, I've got an nth term formula here. The nth term of my sequence is 7n plus 9, and we're going to look at 3 questions. We're going to look at ascertaining which term of the sequence has a certain value. In this case, which term of the sequence equals 464. We're going to ascertain a way of finding out which is the first term that's over 1,000. And we're going to find a way of working out whether or not a certain number is indeed a member of the sequence. So let's look at the first one here. Which term of the sequence equals 464? So we've got the nth term is 7n plus 9, and we're being asked to find out which term of the sequence equals 464. So I need to have 7n plus 9, the term of the sequence, equaling 464, and I have to solve that equation to find which n will give me that answer. So if I do 455 divided by 7, I get 65. So in fact, it's the 65th term of the sequence, which equals 464. What about the second one? Which is the first term over 1,000? Well, in this case, I'm going to want to solve this inequality. I want the value of my term to be over 1,000. Let's find out which value of n will satisfy that inequality. If I subtract 9 from both sides, I get 7n equals 991. And if I do 991 divided by 7, I get 141.6. So n has got to be greater than 141.6. That means that the 141st term would be less than 1,000. And in order to give me a term of greater than 1,000, n must be at least 142. So the first term over 1,000 is the 142nd term. Lastly, how do I use my formula for the nth term, the formula Tn equals 7n plus 9, to ascertain whether or not 186 is a member of my sequence? Well, I'm going to see what value of n would give me an answer of 386. So let's try and solve 7n plus 9 equals 386. Well, in that case, 7n would have to be 386 minus 9, 377, and n would have to be, I wonder if it's going to be a whole number. If it's a whole number, then I've got an answer, but actually n in this case has got to be 53.9 to 1 decimal place. So there's no way I can have a whole number value of n and get 386. So the answer to the question is no. 386 is not a term in the sequence. It's not the 53rd term, and it's not the 54th term. It's somewhere in between, so it is not a term of the sequence. I hope you're finding these films useful. If so, please press like. Mr. Right here, we're going to find out how to find the nth term formula for an arithmetic sequence. Now, first of all, let's just be clear. An arithmetic sequence is a sequence like this one, 5, 8, 11, 14, where the difference between the terms is always the same. In this case, we've got a constant difference of +3. Now, how are we going to find the nth term for that? Well, the first thing to do is to ascertain what that common difference is. In this case, the common difference is 3. That means that my nth term formula is going to start 3n, because my formula is a bit like the 3 times table, and that has differences of 3. So if my formula has differences of 3, it's going to start with an nth term formula that begins with 3n. Now, if my formula was just 3n, then the first term of my sequence would be 3 times 1, 3. And the first term of my sequence is 5. So I'm going to need to have a correction factor of +2. Let's just check that works for the other terms we know. Let's choose this term. That's the 4th term of our sequence. And according to my formula, the 4th term is 3 times 4 plus 2. And according to the question, that should give me an answer of 14, which indeed it does. Let's look at another example of finding the nth term formula for an arithmetic sequence. Here's a sequence. You could pause the film, see if you can do this one, and then watch how I do it, see if we agree. So the sequence is 7, 11, 15, 19, 23. Okay, pause the film if you want to. Right, that's an arithmetic sequence, and the difference between the terms is always the same. In fact, the constant difference is 4. So my nth term is going to start 4n. Now, what's my correction factor going to have to be? Well, the first term of a sequence which starts 4n would be 4 times 1 is 4, and my first term is 7. So it's going to need to be 4n plus 3. And I could check that by looking at the 5th term. The 5th term I know is 23, look. And let's just check, because according to my formula, the 5th term should be 4 times 5 plus 3, and that is 23. Good. Okay, let's have a look at a couple more examples. Let's look at this one. 5, 13, 21, 29. Pause the film if you want to have a go yourself. This time, the constant difference is 8. So my formula is going to start Tn equals 8n. It's like the 8 times table. But 8 times 1 is 8, and my first term is 5. So my correction factor will have to be -3. And we could check that by looking at the 3rd term, for example. According to my formula, the 3rd term should be 8 times 3. Take away 3, which is 21. And if I look at the question up here, I see the 3rd term is indeed 21. Right, last one. Let's have a look at this one. 21, 19, 17, 15, 13. Pause the film if you want to. In this case, the constant difference is -2. So my formula for the nth term is going to start -2n. Now, if that was my formula, then the first term, t1, would be -2 times 1. It would be -2. And my first term is 21. So I'm going to need to have a correction factor of +23 to lift that -2 up to 21. And again, we could check that. Let's check it with the 4th term. According to my formula, the 4th term is -2 times 4 plus 23. Well, that is -8 plus 23, which is 15. And looking at the question here, my 4th term is indeed 15. So that is how to find the formula for the nth term for an arithmetic sequence. If you found this film useful, please hit like. Mr. Right here. There are some other ways in which you need to use the nth term formula for a sequence. And to illustrate these to you, I've got an nth term formula here. The nth term of my sequence is 7n plus 9, and we're going to look at 3 questions. We're going to look at ascertaining which term of the sequence has a certain value. In this case, which term of the sequence equals 464. We're going to ascertain a way of finding out which is the first term that's over 1,000. And we're going to find a way of working out whether or not a certain number is indeed a member of the sequence. So let's look at the first one here. Which term of the sequence equals 464? So we've got the nth term is 7n plus 9, and we're being asked to find out which term of the sequence equals 464. So I need to have 7n plus 9, the term of the sequence, equaling 464, and I have to solve that equation to find which n will give me that answer. So if I do 455 divided by 7, I get 65. So in fact, it's the 65th term of the sequence, which equals 464. What about the second one? Which is the first term over 1,000? Well, in this case, I'm going to want to solve this inequality. I want the value of my term to be over 1,000. Let's find out which value of n will satisfy that inequality. If I subtract 9 from both sides, I get 7n equals 991. And if I do 991 divided by 7, I get 141.6. So n has got to be greater than 141.6. That means that the 141st term would be less than 1,000. And in order to give me a term of greater than 1,000, n must be at least 142. So the first term over 1,000 is the 142nd term. Lastly, how do I use my formula for the nth term, the formula Tn equals 7n plus 9, to ascertain whether or not 186 is a member of my sequence? Well, I'm going to see what value of n would give me an answer of 386. So let's try and solve 7n plus 9 equals 386. Well, in that case, 7n would have to be 386 minus 9, 377, and n would have to be, I wonder if it's going to be a whole number. If it's a whole number, then I've got an answer, but actually n in this case has got to be 53.9 to one decimal place. So there's no way I can have a whole number value of n and get 386. So the answer to the question is no, 386 is not a term in the sequence. It's not the 53rd term, and it's not the 54th term. It's somewhere in between. So it is not a term of the sequence. I hope you're finding these films useful. If so, please press like. Mr. Wright here. We're going to look at how to use the difference method to extend a sequence. Let's start with the question that I've called question 0, which has a sequence which goes 7, 11, 15, 19. Looking at that and using the difference method, I work out the difference between each of the terms, 7 to 11, 11 to 15, 15 to 19. The difference is 4 each time, so I can extend the sequence by adding 4 onto 19 to give me 23, and then adding 4 on again to give me the next term of 27. And I can continue to extend the sequence in that way. Let's have a look at question 1. Now, question 1 has a sequence that goes like this: 1, 3, 8, 16, 27, 41. Again, I'm going to use the difference method. You might like to pause the film and have a go before me. Right, 1 to 3, that's plus 2. 3 to 8, it's plus 5. 8 to 16 is plus 8. 16 to 27, plus 11. And 27 to 41 is plus 14. Now, to help me see what's going on here, I'm going to find the difference of the differences. From plus 2 to plus 5, that's plus 3, plus another 3, plus another 3, plus another 3. Right. So if I want to find the term which comes after 41, I'm going to plus 3 on here, which is going to make this plus 14 a plus 17, which means that this term is going to be 41 plus 17, which is 58. If I wanted to continue the sequence, I could have another plus 3 here to give me a plus 20 here to give me 78 there, and so on. Right, here's number 2. The sequence is 1, 6, 9, 10, 9, 6. Perhaps pause the film, find the differences between those terms, and see what you can figure out, and then see how I do it. Okay, so the differences between the terms, we've got +5 here, then I've got +3, then I've got 1, +1, now I've got -1 and -3. Okay, well, let's find the difference between the differences. So 5 to -3, I've taken away 2. 3 to 1, take away 2. 1 to -1, take away 2. -1 to -3, take away 2. Now I can see what's going on. So to find this term and this term, I'm going to need a -2 here. -3 take away 2 is -5. So 6 minus 5 gives me 1. And now to find the next one, I'm going to -2 here. -5 minus 2 is -7. 1 take away 7 is -6. All right, let's try number 3. Here's the sequence for number 3. 1, -4, -7, -8, -7, and -4. Let's start by finding the differences between those terms and then perhaps the difference of the differences. Pause the film and have a go. Okay, from 1 to -4, I've taken away 5. Now I'm taking away 3, then taking away 1. Now I'm adding 1, and now I'm adding 3. Okay, let's find the difference between the differences. From -5 to -3, I've added 2. From -3 to +1, I've added 2. From -1 to +1, I've added 2. From +1 to +3, I've added 2. That's making sense now. I need to find this term and this term. So I've got +3. I've got a differences of +2 along here. So +3 + 2 gives me +5. So -4 + 5 is 1. Right, let's carry on the +2s along the bottom. +5 + 2 is +7. 1 + 7 is 8. There we go. So that is how to find the next terms of a sequence using the difference method. If you found the film useful, please hit like. Mr. Right here, we're going to learn how to find the sum, the total of an arithmetic sequence. So, for example, what do I mean by the sum of an arithmetic sequence? Well, this is an arithmetic sequence, 4, 7, 10, 13. It's an arithmetic sequence because the difference between the terms is always the same. In this case, the constant difference is 3. Now, to find the sum of an arithmetic sequence, that might mean, for instance, finding the total, the sum, the total of the first, should we say, 100 terms. So what I'm being asked to do, I'm being asked to continue the sequence until I've got 100 terms, and then add up all those 100 numbers. Right, the way that we do this is we use a formula here. Now, the formula is given to you on the formula sheet when you do your exams, but I will make another film that explains how the formula is derived. But in this film, let's just get on and use the formula. So our question is to find the total of the first 100 terms of the sequence that starts 4, 7, 10, 13. Now, we're asked to find the first 100 terms, so n is 100. A in the formula, A being the first letter of the alphabet, A is the first term of the sequence, which in our case is 4, and D in the formula is the difference, and in our case, the difference between each of the terms is 3. So that's all we need to know now to work out the sum of the first 100 terms. So our formula is that the sum of the first 100 terms will be n over 2, that's 100 over 2, multiplied by 2 times the first term, 2 times 4, plus n minus 1, well, 100 minus 1 is 99, times d, which is 3. So that is what we have to work out. So on my calculator, I'm going to do 2 times 4 is 8, and I'm going to add that to 99 threes. And so I've got 50, 100 over 2, multiplied by 305. And so the sum of the first 100 terms of that sequence is 50 times 305, 15,250. Right, perhaps you ought to try one. So I'll start by writing down that formula for you. The sum of the first n terms is n over 2 multiplied by 2a plus n minus 1 d. And let's find the sum of the first 50 terms of this sequence. Let's have the sequence that begins 10, 13, 16, 19, and so on. Can you find the sum of the first 50 terms of that sequence? Perhaps pause the film, give it a go. Okay, so the sum of the first 50 terms, S50, is going to be 50 over 2, n over 2, multiplied by 2 times the first term, 2 times a, plus 49, n minus 1, times the difference, which is 3. So that is what I need to work out. So that's going to be 25 multiplied by, I'm just working out the bracket now, 49 times 3 plus 20 gives me 167. So the sum of the first 50 terms is 167 times 25, 4,175. Okay, so that is how to find the sum of an arithmetic sequence. If you found this film useful, please hit like. Pause the film now to do the question before me. Right, so the sum of the first 100 terms is going to be 100 over 2 multiplied by 2 times 7, 2 times the first term, minus 99, 100 minus 1, times the difference, 3, which is 50 multiplied by 311. And on my calculator, that's 15,550. Pause the film now to do the question before me. Right, an expression for the nth term of that sequence. Well, the constant difference is 6, so it's 6n, and the first term isn't 6, it's 10. So my nth term formula is 6n plus 4. Now I'm given another details of another sequence t here, and t, the terms of t are always 3 less than a square number. So I've got to find a number which would be in both sequences. So I'm going to continue this sequence by adding 6 each time, looking for a number which is 3 less than a square number. Oh, I've already found one. Look, 46 is 3 less than 49, so would be in the sequence T and would also be in the sequence S. So my answer is 46. Pause the film now to do the question before me. Right, in part A, I've got to write an expression in terms of n for the nth term. Well, the constant difference is 4, and the first term isn't 4, it's 6. So the nth term formula is 4n plus 2. Now I can use that to write down an expression in terms of n for the nth plus 1th term, because if the nth term is 4n plus 2, then the nth plus 1th term is 4 times n plus 1 plus 2, which I can simplify to 4n plus 6. Pause the film now to do the question before me. Now the numerators are the sequence 1, 2, 3, 4, so the nth term of the numerator is simply n, and the denominators form the sequence 1, 3, 5, 7, so the nth term for the denominators is 2n minus 1. So the nth term for my sequence of fractions is n, the numerator, over 2n minus 1, the denominator. Pause the film now to do the question before me. Right, the next 2 terms, well, my sequence is going up in 4s, so 27 and 31. Give the term-to-term rule. Well, to move from one term to the next, one simply adds 4. And write down the formula for the nth term. Well, it's going up in 4s, and the first term is 7 rather than 4, so the nth term is 4n plus 3. Pause the film now to do the question before me. Right, we need to write down the first 5 terms. So 2 times 1 plus 2 is 4. 2 times 2 plus 2 is 6. 2 times 3 plus 2 is 8. Now, as I carry on, I can continue in the same way, or I know it goes up in 2s. So 10 and 12. Work out the 100th term in the sequence. Well, it's going to be 2 times 100 plus 2. So it's going to be 202. Now to do the question before me. Here are the first 5 terms, and I've got to write down the next term. But it's going up in 4s, so the next term will be 25. Find the nth term of this sequence. Well, I know that it's going up in 4s, so the formula is going to be 4n, and then in this case it's going to be 4n plus 1 because the first term is 5 rather than 4. Hence or otherwise find the 47th term. So the 47th term is going to be 4 times 47 plus 1, which gives me an answer of 189 for the 47th. Pause the film now to do the question before me. The nth term is 4n minus 2, so the first term is 4 times 1 minus 2. The second term is 4 times 2 minus 2. I can carry on like this, or I can see they all go up in 4s, so I can simply continue by adding on 4. The position number of the term with the value of 82, well in that case 4n minus 2 must equal 82. What's the value of n? Well, 4n will be 84, so n will be 21. So it's the 21st term. Explain how you know whether the number 80 will occur in the sequence or not. Well, the sequence goes up and down goes up by 4 each time, and 82 is the 21st term, and so the one before that will be 78, not 80. So that's how I know that 80 will not occur. Pause the film now to do the question before me. So the sum of the first 48 terms, as 48, is given by 24 multiplied by 2a plus 47, n minus 1, d. And in the same way, the sum of the first 36 terms is 18 half of n multiplied by 2a plus 35d. And we know that the sum of the first 48 terms, 24 lots of 2a plus 47d, is equal to 4 times the sum of the first 36 terms. Okay, so I've got an equation there with a's and d's in it. I'm going to multiply out both sets of brackets to give me 48a plus 1128d equals 144a plus 2520d. Rearrange that. Minus 96a on the left equals 1392d, and so a is minus 14.5 times d, dividing both sides by 96. Now we're asked to find the sum of the first 30 terms. And the sum of the first 30 terms is given by the formula S30 is 30 over 2, multiplied by 2a plus 29d. Let's substitute our expression for a into this formula. We're going to have 15 multiplied by 2 times minus 14.5d plus 29d. Let's continue to simplify that. That's 15 times minus 29d plus 29d. Well, that's 15 times 0. So the sum of the first 30 terms is 0. Pause the question now to do the question before me. Right, we need to write an expression for the nth term of this sequence. Now the nth term is going to be n lots of n plus 1, because, for example, the 6th term is 6 times 7, and that's going to then be divided by 2. So there's an expression for the nth term of this sequence. And we're proving algebraically that the sum of any two consecutive terms. So we're going to need to know the generalized form of the next term as well. So the n plus 1th term. Well, if the nth term is n lots of n plus 1, then the n plus 1th term is going to be n plus 1 plus times n plus 2 over 2. So there's an expression for two consecutive terms, the nth term and the n plus 1th term. Now I've got to look at the sum of those consecutive terms. So I'm going to add up my two algebraic expressions. I've got n lots of n plus 1 over 2 plus n plus 1 multiplied by n plus 2 over 2. Let's write that under the common denominator. Let's multiply out that bracket n squared plus n plus, now I'm multiplying out n plus 1 lots of n plus 2, n squared plus 3n plus 2. I'm going to simplify the top there. I've got 2n squareds plus 4n plus 2, and that's all over 2. So if I halve the top, I'm left with n squared plus 2n plus 1. So there is an expression for the sum of any two consecutive terms. And now I need to prove that that expression is always a square number. Well, if I look at that expression equals n plus 1 squared. So the total of the two consecutive terms of the sequence is always a square number because it can be written as n plus 1 squared, as something squared. Pause the film now to do the question before me. Now we know that the first term of this sequence is minus 6, and we know that the sum of the first 30 terms is 2,865. So an expression for the sum of those 30 terms is n over 2, 15, times twice a plus 29 times d. And we know that that equals 2865. So I'm going to get an equation here which will enable me to find d. I've got minus 180 plus 15 times 29, 435 d equals 2865. So add 180 to both sides. 435d is 3045. Divide both sides by 435, and d is 7. So now I know the first term is minus 6, and I know the constant difference is 7. I'm asked to find the 9th term. So that will be the first term plus 8 of the differences. And so the 9th term will be 50. Pause the film now to do the question before me. Now we know that the 25th term is 44.5. So that tells me that a plus 24 differences is 44.5. Let's come back to that in a moment. We also know that the sum of the first 30 terms is 765, which means that we know that 15 times twice a plus 29 differences equals 765. So that tells us that 30a plus 29 times 15, 435d, equals 765. So now I've got two equations. I've got 30a plus 435d equals 765, and I've got a plus 24d equals 44.5. So if I solve those simultaneously, I'll be able to find values for a and d. Let's multiply the second equation by 30. Gives me 30a plus 720d equals 44.5 times 30, 1,335. And now let's do this equation here, subtract this equation here, because the a's will disappear and I'll be left with 720d minus 435d gives me 285d equals 1,335 minus 765, 570, and hence D is 2. Substitute that value for D into one of your equations, and you'll find that A is minus 3.5. So now I've found A and D, and I'm asked to find the 16th term. So the 16th term will be the first term, minus 3.5, plus 15 of the differences, 15 times 2, which is minus 3.5, plus 30, which is 26.5. Pause the film now to do the question before me. Right, I know how to work out the sum of all the first 100 terms. But we don't want the sum of all the 100 terms. We want to lop off all these ones because we only want the sum of the terms from the 50th to the 100th. So what I'm going to do is I'm going to find the sum of the first 100 terms, and from there I'm going to subtract the sum of the first 49 terms, because then I'll be left just with the total of all the terms from the 50th to the 100th, including the 50th and including the 100th. So the sum of the first 100 terms is going to be 50 multiplied by twice the first term plus 99 times the common difference, which is 7. And from there, I'm going to subtract the sum of the first 49 terms. 49 over 2 multiplied by twice the first term plus 48 of the common difference, which is 7. So if I work that through on my calculator, then this first expression comes to 35,450. That's the sum of the first 100 terms. And the first 49 terms, they total to 8,624. So the sum of all the terms from the 50th to the 100th term inclusive is 26,826. Pause the film now to do the question before me. Right, I'm told that the 6th term, which by the way is the first term plus 5 differences, equals 39. And I'm told that the 19th term, which by the way is the first term plus 18 differences, equals 7.8. So I can solve these equations simultaneously. If I do equation 2, subtract equation 1, I find that 13D is equal to minus 31.2. And so dividing both sides by 13, D is equal to minus 12 fifths. Substitute that into either one of the equations, and you will find that A, the first term, is equal to 51. Right, the question asked me to work out the sum of the first 25 terms. So that's going to be half of 25 multiplied by twice A plus 24 of the differences. The difference is negative, so just make sure you work your way through this carefully on your calculator, and you will find that's 12.5 multiplied by 44.4, and so the sum of the first 25 terms is 555. So that concludes all you need to know about sequences for your IGCSE exams. Well done for sticking with it, and I hope you found the film useful. A final plea, please do hit like if you found the film useful, and if you'd like to, please head over to my own YouTube channel where everything is focused specifically at helping you ace your Edexcel IGCSE Maths exams. Good luck, and thanks for watching.